Where is... Okay. Now, if the audio isn't loud enough this time, then I don't know what's going on. Okay, where is my studio? How's everybody going today? Today we got a neural networks problem, and we're going to start off with something I found recently. Where is my chat that comes up? YouTube live control panel. All right, this is going to be very useful if I don't have my chat up. Oh, that sounds way better. Okay. Put this over here. All right. Okay, so the first thing I'm starting off with is this awesome website that I found called Brilliant. Yeah, let's do this. All right. Which is kind of like gamifying learning. So the one thing that I did as an undergrad was I was mechanical engineering, switched to biochemistry, did a bunch of math, but I graduated in 2011, went to law school, did not touch a majority of math throughout the years, except for like basics, doing, just more like business calculations. So now I need a refresher. And actually, it's amazing how much calculus I actually remember. So, because of machine learning, I want to start and continue with algorithms and data structures. All right, memory addresses. Your computer has a fixed amount of storage. Wonder if I can just increase this size of this. Variables, records, and all their data structures live in computer memory so they can be accessed later. How are data structures stored in computer memory? We could think of computer memory as consisting of a sequence of numbered locations. When we create a new data structure, the computer finds a spot and tells us where the new... Yep. Here's a record containing information. The mayor's name is Jing. The contact 7801. Name, yeah. What address is the record stored at? Wait, what? What address? According to the 7 where the record is stored at, the variable the contact does not contain our new contact, contains the address. Yeah. After the following contact, what's the value of the new contact? Set new contact to contact. Wait, what? After creating the following contact, what's the value of the new contact? Oh, this. No, we can't tell. That's what I said before. The actual address to which the contact is stored in the arbitrary and would be many numbers. It is not used. For this reason, instead of always referring to a record by its address, we use shortcuts. These two guys refer to the same record in the memory, one with addresses, one without. Seminal is important. Okay. In order to access the contents of the record, we'll use arrows as shorthands. Based on the above code, new contact name corresponds to the value Don. Yep. I kind of don't like the pseudocode because usually you do it by, well, I guess that's column name, but then they're calling A, which should be an index number. So this should be 0 and this should be 1. So maybe that's throwing me off. Memory addresses are just numbers, and it's possible for them to overlap. This diagram is almost identical to the last one, but note that the contents of the B variable have changed. Oh, they're just calling it a B variable instead of the index within a data frame. Okay, it's changed. What's B row, A column in this diagram? B row, A column. The diagram is almost identical, but note that the contents. Oh, B row plus A column in this diagram. The hell is it talking about? So B row locates the value 1 in the row field. Okay, I don't like... So B row locates the value 1. Why is that B row when B row is 6? Okay, I quite don't understand. In this example, we saw that A and B both contain the memory address of the same record. Oh. It's possible for the same memory to be stored in two different variables called aliasing. Yes, I'm aware of that. In this diagram, how many aliases are there for the third record? The one containing Jings. There's 3. Boom. We can use arrows as shorthand in the diagrams as well. What is B row plus A column in this diagram? Why? The variable B contains the memory address of the first record, contains 1. The variable A contains the memory address of the second record, the column. Oh, because it's not... Okay. So if I go back up here, because it's aliasing, it's just going to point me 193 to the first. And down here, there's separate values. So I should have... Okay. We can spot aliasing when it occurs in an arrow-based diagram because the two arrows point to the same field. Review and reflect. We've seen how data structures... Okay, finish the lesson. Boom. Done. Can't say I like how that was done, because I would never be pointing to the same record. Like aliasing, sure, when there's same values or duplicate values within a given column. But if I'm pointing to anything within Python, I'm pointing generally to an index or some sort of unique assigner, like an ID or something. So that was confusing me. But I guess if I don't have that option to point to something unique, or even the index, which I would always have an ability to point to an index, I guess, yeah, that's where I need to know this. So we're talking about generalities when it comes to programming. All right, manipulating pointers. Program can update the value of a variable by referring to its name. Similarly, a program can update a field of record using a pointer, like so. Set dog spots to dog spots plus 1. Set x to 7 minus dog spots. set cap position to row to 4 plus x. Okay. Boom. Let's make sure we understand this. Set x to 7 minus dog spots. So change -9 to 7. Subtract 5. 2. Set cap position to row to 4 plus x. 6. Cap position contains the addresses of a record, which contains 2 fields, row and column. It is used to store the ever-changing whereabouts. After this code runs, what will be the value of cap position to row? Set cap position to row to 2. Okay. Column to 5. So 2 and 5. So set cap position 2, column, row, plus 1 will 6. Consider 2 variables, cap position and dog position, which locate the positions of a cat and a dog on a game grid. The 2 variables, cap position and dog position, contain 2 different addresses for 2 different records, but you don't know the contents. Okay, dog position, row to 2 to 5, set row to row plus 1, 3. Now suppose instead the variables cap position, dog position contain the same address in memory. Set dog position to row 2, cap position row to 5. So it changed from 2 to 5. Sure. Set cap position row to dog position row. They're both 5, 6. Got it now. Now we're cooking with gas. All right. Note the same code led us to different answers depending on the underlying addresses in memory. This is an example of aliasing, and it can lead to surprising outcomes. Boom, boom. Changed. Yep. Okay. That's what we got. Now we'll consider what happens when we manipulate entire records in code. The contacts for Ann and Don are represented by variables in the diagram. Don, Ann, yeah. What will happen when starting in the world above, you run this command. Set Y to contact B5. It's going to change. It's going to replace. No, X goes to Don, Y goes to Ann. I guess that's B and Ann. Why wouldn't it just replace? There will be arrows pointing to Don. Oh, it is replacing. That was confusing. Okay. Yeah, I misunderstood. All right. In the exercise below, we'll predict the result of each program, specifically the outcome of announce function. This program creates 2 records, then calls announce. Set A to contact Ann, set B to contact, announce A name, announce B name. What gets announced in the program above? So if announce was like print, then it would have to be Ann and then B. This program is similar but continues a new command. Set B to A. Set A to contact. Set A to contact. Sure. Set B to contact. B. Then set B to A. Announce A name. Announce B name. First and then B. No, it'd have to be B. BB? First and then again. I'm just getting confused because if you were to write this and you replace, okay, I get why that's the outcome of this. The order of commands is key. In the previous example, set B to A is called. Our new diagram memory, so it points to it. Oh, so B was changed to A, not B was moved to A. Let's see what happens when we have multiple calls to set. Set A to An, B to B, set A to B. Okay. So now we have BB. And then we have, so we have BB. And then we have B to A. Set A, okay. Set A to An, B to B. Okay, that's our initial start. But then, just like the last one, we set A to B. So now B's being called on twice. But then B goes back to A. So An gets called again. Give me explanation. Let's pull it all together. Set A to An, B to B. Set C to B. Set C name to A name. I feel like I need a pen and paper. Why would you ever do this? So A's An, B's B, C's B. So you get BB. So you have An, B, B. But then it goes An, B, An. An, B, An. Get out of here. Now for a challenge, write your own program. Consider the following. Arrange the command so that An and B's names are switched. In other words, A's name is set to B and B is set to An. You don't have to use all the commands. Arrange the command so that An and B's names are switched. So I want to do like set, if I do set A to C, and then B to A. No. So B to C. A to B, C to A. You've overwritten B without first copying it somewhere and no longer have a way to refer to B's record. That's a good point. Okay, so B to C. So B to C. So now we have B at C. So this should be C. Or the pointer goes down here. Oh no, I have... So I have ACC. But then if I change A to B, I have BCC. And then Anna, or Anne, is B. Wait, that's what I did last time. And it said that. Okay, start over. I guess I could do multiple pointers than just moving stuff, huh? Like I can set C to A. And now we have 2 pointers to Anne. That'll happen up here. Announce a name. I want to switch them. This would be so easy through code, but what is it wanting me to do? Arrange the words so that Anne and B's names are switched. So I need to move. We'll have multiple pointer. Well, no, that's okay, let me just try something different. The pseudocode's like throwing me off. I mean, it's kind of pseudocode. It's kind of SQL, ain't it? Set B to C. Arrange the command so that Anne and B's names are switched. All right, I need coffee. My brain's not prepared for this. I don't get why I don't have a C to B. Well, these are the tools I got. Okay, so if I do C to A, I now have 2 records pointing to Anne. If I do A to B, I have 2. That'd get rid of Anne. Everything's got to be assigned in a memory. Okay, so I get it in that context. So Anne or B need to be pointed to twice, but which one makes more sense? If I have a C to A, and then no, that get C to A. Because now I have 2 A's pointing to Anne and 1 B. But I didn't get Anne to B and I didn't get B. Oh, I just want to go program. But why can't my brain wrap my head around what it wants me to do here? Okay, I need to go back up here and see exactly what the hell is going on with this. Because I got this wrong. So I set A and B. You set A to B. You get 2 contacts at B, and then B to A. And it calls on B again. Because you have 1 announce A name, announce B name. Set A to B. Yeah, it didn't get rid of. Oh, got rid of B. Okay, remember when commands run at a time, one at a time? Sure. The third command will cause both A and B to have the same contents. That's what I don't get when it's doing this, because if you set B to A and you have two B's, why in this like pseudocode it doesn't just change both B's to A? Because this should be blank normally if you're changing A. Okay, but that's besides the point. I'm just going to try to figure out the logic of what this is trying to do. Both A and B are already in the address. Okay, this is the assumption that I'm making. But to me, it's not making a lot of sense. So it's keeping it in memory. And it's only allowing me to make, okay, so C to A, which can't be it, I don't think, because I can't change it back to B. Set B to C. So do I move U first? Set B? No. Can't do that. Just give it to me. Use arrows solution step by step. You can swap the pointers in A and B. Okay, that was C to A. Okay. To avoid losing track of the value that you're about to write over, you need to store one of them in auxiliary assignable. Okay, sure. Then A to B. So you set C to A, and then A to B. So you have two B's, and you still have an at C. And the next is going to be B to A, B to C. What? All right, I'm over it. Get out of here. Finish the lesson. Oh. Now before we go into here, I know they got neural networks. Yeah, let's jump ahead. Can computers learn decision box, activation, classification, sigmoid neurons, training single neuron? Okay, I did all this. All right, we are just going to jump right into it because my brain was not ready for that. New notebook. Let's say what I'm working on is a project for class. So I can't reveal some of the resources that I'm going to have in my screen over here, but I'll just show as much as I can. Was this project 4? Neural networks. All right. And then over here, I want to pull up my class projects. Let's see. Bank churn. All right. What is the goal? All right. Well, we can put it here. The problem statements. And the more boring part about all this is I got to do the exploratory data analysis. We always start over from scratch. So before I even get into the neural networks and the training, I start off with that. All right. So, let's see, actually, I usually have, let's see, upload full code submission somewhere. Where are you? Boom. We'll go to neural networks. Here it is. Okay. All right, so we got the problem statements. How do you do this? Oh, okay. Okay. Text. Objective. Just formatting. So then we're good to go. 1, 2, 3. Data, dictionary, data set we're working with. So this should be, from what I can tell, a simpler classification neural network model. Okay. That appears to be everything. Okay, problem statement, context. Businesses like banks, which provide service, have to worry about problem of customer churn. We just did a last project where we used a gradient boost model, which was XGBoost, in order to do that. And I think I can pull that up now. Where is that? Full code. I think this was my last version, maybe? Yeah. So we just did this one, which was churn rate for credit cards, but we used a less, I don't want to say sophisticated model, but you can see this is all the exploratory data analysis you got to go through. You got to clean it up. You got to impute missing values. You got to do all that and look through it. Oh, this is actually my second project. This ain't even the last one. This was actually another decision tree, which was pretty cool. Figuring out how to improve campaigns for marketing companies. Where's my full code? Full code project 3. Where you at? It's got to be in here. There you are. Final. Yeah. You gonna get mad at me, Google Colab, for not paying? Okay, so yeah, these were all different classifiers, which was fun to do. Exploratory data analysis is not fun. Go down here, and then all the different kind of pipeline development, business insights, model comparison. This was a lot of fun, but yeah, I don't want to say this is less sophisticated, but I think neural networks are generally what people think about when you're thinking about machine learning. So the first thing we're going to do is read. Okay, businesses like banks, which provide service, have to worry about the problem of customer churn. Sure, customers leaving and joining another service provider. It is important to understand which aspects of the service influence a customer's decision in this regard. So same as last time with this project. You go through here, you can find feature importances, you can do correlation analysis, you can look at, different charts of all the different data sets, and you can see what is related, what matters. Then you let the model run itself, do all the tuning and everything else, assess performance, see exactly, and you can see here what customer churn looks like. So the target that we're looking at here is to make sure the predicted label aligns with the true label as much as possible. And you can do these cool little confusion matrices to see that. So like in this model, you can see that identified the 313 that were actually, yes, these will churn. And I missed 12 of them. So, I mean, you're not going to be 100%. If you're 90% accurate, which this one was, this was 94% accurate, that's pretty damn good. And then here you would want to limit as many false negatives as possible, and false positives is fine. But from a business standpoint, the thing to worry about is kind of resource allocation. So when I predict that 110 customers could potentially churn and they don't, then we have to think about the fact that there's customer retention cost, and going after those customers when they don't actually churn could be an issue. So then it becomes more outside of the realm of what the machine learning engineer is doing, the business analyst. needs to take over and kind of assess that balance. And between accuracy, so recall is the reduction of false negatives, precision, the reduction of false positives, and then an F1 score is the balance between the two. So if you decide that we need to actually balance these and we're okay with customer churn because regardless of identifying them, they're going to churn, then you want to understand that balance. So back to the neural network. Okay, so the first thing we're going to do is we're going to import the appropriate libraries, which the only way I know how to do that is from continuing to work, importing libraries as needed, and then also referencing past projects. So that's what I'm going to do, is look at some past projects and just understand. We always know like the data libraries, which are always going to be import pandas as PD, import numpy as NP, import matplotlib, pyplot as PLT, and then Seaborn for data visualization as well. Now, I am going to do that. I guess I'll stay away from Plotly because we have to export our projects to HTML. And Plotly is a pain in the ass. Maybe make this bigger. People can see. Okay. Okay, well, why can't I just... That's fine. So we have data libraries. These are my data visualization libraries. To avoid warnings that I don't care about. What else? We do want test and train split. So that's from sklearn model selection, import train test split. I don't know if we need a scalar. Oh, we need the neural network libraries, neural network libraries, which is going to be our TensorFlow. TensorFlow as TF from TensorFlow import Keras. What else does it want me to do? Optimizers is Atom, import dense dropout, which I will need from TensorFlow Keras layers. Import was it dense and dropout. I don't know what my optimizer is going to be. But I'm sure I need one. Do we want to review model performance? So we definitely want classification report, confusion matrix. Yeah, I want all that. Accuracy score, yes. Stop it. Rock curve, recall, score, precision. Give it all. F1 score. Yes, please. And I think that's it for now. So I can run those libraries, make sure they're all installed. Add this, import libraries. Build another network to build or not with in the next 6 months. Okay. Objective, customer ID. Okay, let's look through the data information. We have customer ID, which right off the bat, I'm assuming we're going to remove because like when I was doing the brilliant exercises, there's some unique identifier already, which is the index of a data frame. So you get the last name of the customer, credit score, geography, customer's location, gender, age, tenure, which is the number of years the customer's been with the bank, the number of products they have with the bank, very similar, the account balance. Again, this is them just leaving the bank. This has nothing to do with credit cards like our last project, right? Leave the bank. Okay. Estimated salary is an active member. Exited, yes or no. Okay, so now I need to import. Nope, that's not what I wanted. Import data set. Now the wonderful data analysis from Google Collab, import drive mount. Yes, please. Just in case anything comes about, we're going to connect. Don't know if there's any personal information that pops up when I connect a notebook. We are connected. Okay. Oh, nope. Stop. Refresh drive. And I need to upload the data sets somewhere. Oh, here's my folder. Project 4. Where's my stuff? Neural networks, where are you? There you are. Churn. Boom. Okay. Cool. All right, now I can go back. This will be churn data. PD read CSV. Copy path. Boom. Boom. Now we got the data. And as always, for good hygiene, I will do df equals churn data copy. Yep, you got it. Now we start the boring part, exploratory data analysis. All right, so first things first, what do we got? We got row number. What do we have row number? It's not even in here. Row number? DF head. Let's take a look at it. So we need to delete row number and then customer ID, I'm sure. So if we look at DF shape, it's going to tell us how many rows, 10,000 and 14 columns. Exited is our target. Okay, so initial review, we'll make a separate section. We'll call this initial data review. We can see here we've got integers, we got objects, which is going to be the names. We have geography, their location. We've got male or female. which we could probably right off the bat just change to ones and zeros, because the thing about any machine learning model is not going to handle strings. It's called, they're objects here. They are type strings. It doesn't handle that well. Geography, we're going to have to look into. Credit score is continuous. That's good. Balance, tenure. Is active member and exited. That doesn't make any sense. Is active member. What are you? Is active member is a categorical variable which decides whether the customer is active member of the bank. Active member in the sense that using bank products regularly, making transactions. I'd be curious because, like, I'm assuming one active member of the banks. I'm assuming one means they're active. But what does that matter if they leave? So right off the bat, when I'm looking at this data, I'm assuming, first of all, row number is going to be gone. We're going to drop that. Customer ID is gone. We have to change surname. Actually, I bet the first three columns are going to be useless. Geography, we're going to have to change. That'll probably become different columns. Gender should be probably changed to zeros and ones. Age should be fine. Tenure should be fine. All that's fine. Is active member and exited is going to be an interesting one. So we'll do like initial data observations. That's not what I wanted. We're going to go ahead and say, why is it doing that? Yeah, okay. Initial data observations. Looks like row number and customer ID are unique and will not provide value since we already have that covered from index. Meaning we already have this. So in a data frame, they're already signed an index, so you can call upon it by location. So there's no way there's going to be a correlation between a unique value, either row number or customer ID, to help the machine learning model even find any value in it. So it needs a little help from there. Therefore, we're going to drop those columns. Now the other things, we've got 1, 2, 3 object columns. 1, 2, 3, yes. We have 3 object columns that will need to be treated later on. However, surname will likely also need to be dropped. Like, what if we're just thinking about common sense? Like, could surname have any sort of value unless we run it, we look at value counts later on, and we see like this whole family never leaves the bank or they own the bank? I don't know. Needs a closer look. And then what else we got? Gender will need to be adjusted to integer values of 0 and 1. Is active member needs a closer look as needs a closer look as needs a closer look. Just looking at the first 5 rows, we can see that even if the customer is active, they still can attrite. That looks like just about everything I need to cover. Okay. So I want to go ahead and just drop the columns I know that need to be dropped. I guess we should be careful. I'm going to double check. I should check for duplicates. df duplicated sum. None. Okay. And then df is null sum. Wait, really? You're telling me all the projects we've had null values, and in this one, we have values for everything? Okay, I'm 100% happy with that. So there are no null or duplicated values in the churn data set. I'm 100% happy with that. Cool. All right, so what have we done so far? We've imported the data. We've reviewed it initially. We can see all the different rows. We know we're going to drop row number and customer ID. That's going to happen. And this verifies it. There's, well, I guess that would be, yeah. Okay, so now we can jump to, this was exploratory data analysis, initial review. How many did I put there? 3. Now we're going to do univariate analysis. We're just going to look at column by column, and that way we can confirm with 100% certainty that we can drop some of those columns. Actually, this goes underneath. No, that's right. Univariate analysis. So I want to look at row number. So we're going to do df row number and unique 10,000. Okay, so that confirms it. And then we want to do df customer ID 10,000. Okay. So now drop row number customer ID just to double check, we reviewed the number of unique values in each of the columns above and confirmed that there are the same amount of unique values as there are rows. So we'll move forward with dropping these values. Just double check, review the number of unique values in each of the columns above and confirm that there are the same amount of unique values as there are rows. We'll move forward dropping these values. Let's go. So that goes like this. df drop. I hate that it does that, but it's so easy. Okay. Boom. And they gone. And just to confirm, they gone. So now we have surname. I guess I should have checked surname first. What if we do surname? $2,932. I'll do that somewhere else. Okay. So put text 1, 2, 3, 4. Oh boy, okay. So I just want those to be looped together. We don't need that. Texts. Next is surname. Guess we should have. I can go ahead and just create these kind of columns. 1, 2, 3, 4. Credit score. Wait, do I want to do it this way? What's the code? So if I go here, I know I have code. I just want to look at all of it at once. Where are you at? This, there we go. There we go. We'll look at surname first. Oh, shit. How'd you get back over here? Yeah, what are our objects? Row number, customer ID. So we had surname. Kind of want to look at, do it this way, categorical, right? And then I can change this to that to fall under there. Because we had gender, geography, and surname. Okay. Gender. So this will be geography. Two, 3, 4, 5. And this will be gender. And then we'll do numerical. 1, 2, 3, 4. Numerical columns. And there is where we'll pull so we can run a bit of code up here first. We'll do df num equals df select includes. Can I just do number? Right? Yeah. And then df cat. Why did it do that? I don't know. Df cat equals df select d types exclude number. Now we got 2. I can do my categorical. So for surname, this is where I want to do the df surname. So we got a lot of Smiths, Scotts, Martins, brokers. Do we care? That's going to be the question. That is the $1 million question. So for categorical, stacked bar plot. I've got some functions over here that I'm looking at that I've written before. And in order to save time, I guess one thing I didn't do was look at the statistical summary, which would look like this: df describe, and then transpose it to get it the way I like it. 850. No one's got to have 850 credit score. Get out of here. Age 92. So assumptions are going to be that at a certain point they're just not going to leave because it's not worth it. Balance. How much money this guy's got? $250,000 sitting there. Nice. Number of products, 4. Has or doesn't have a credit card. So we have true or false for has credit card. Is active members, true or false. Estimated salary. Someone's making a couple $100,000 a year. And then exited. Okay. I guess I should add more observations here. So, what do we have? We have has credit card. We have 3 columns that are basically true or false, which are has credit card, is active member, and our target column, which is exited. Right? 0, 1, 0, 1, 0, 1. Number of products. The bank offers at we can assume that the bank offers 4 total different products, since that's the max in that column. This can be either categorical or numerical, but we'll leave as is numerical. The less treatment, the better. 10-year balance. Okay. So now we go back to doing the analysis, but I need more coffee. So I'm going to get more coffee. All right, I'll be right back. Good looking out. Appreciate it. That's been on mute for a while, I guess. So we get age, credit score. All right, I think we can just jump into bivariate analysis. That's what's going to happen. Text C. Bivariate analysis. And this is definitely where I'll need to call on the functions that I've done prior. Where are you? Bivariates. Where are my functions? There we are. Histogram box plot, don't need. Labeled bar plot, don't need. Okay. What I will need are these. And I am just copy pasting these because these are long. So we have a stack bar plot, so we can compare certain columns to our target column. We'll run that. And then we have this distribution plot. Come on. That we can also leverage. Okay. So everything's going to be looking at exited verses. What are the most interesting? Oh, let's run a correlation plot first. How about that? How about that? Looking for some code over here on a prior notebook. Come on. Yeah, this is what we want? Yeah, this is what I want. No, I don't want to use Plotly. Okay, what is write Python code for correlation matrix in, is it Seaborn? I'll just see what it comes up with. Matplotlib. Okay. Put this over here. It is Seaborn. So figure size, fig size equals 10.5. And then I want, SNS heat map. DF correlation, true, cool, warm, PLT show. Could not convert string France. That's why I want DF num. There we go. That's what I want. Okay. So if I can look at this, I want to know what's most correlated. And I'm not, okay, so age. We've got some strong negative correlations. So the number of products related to balance is negatively correlated. That's interesting. Nothing generally here. How about number of products? Number of products and exit has negative, like little to no correlation. Here's kind of a good correlation. Age and exited. I'm assuming, my assumption would be the older you are, the less you are to leave. Like how many times do you actually leave a bank? Yeah, okay. So observations, we have the strongest correlation we have is a negative correlation. Interesting. So if I do observations from correlation matrix, I have such a bad habit. If you do shift enter, you run the cell. And I'm just so used to doing that I keep exiting out of the cell. Strongest correlation is a -1 between num of products and balance. The second strongest, age and exited, which is what we want, target variable. Second strongest is a positive correlation between our target variable, exited, and age. We can assume that the older someone is and the longer they've been with the bank, the less likely they are to attrite. But is that true? Tenure. So tenure and age is showing no correlation. So maybe that's wrong. However, there is little to no correlation between tenure and age, which is odd, right? If I go back up here and I can see tenure, how's that defined? Tenure is number of years which the customer has been with the bank. Interesting. But everything's in the eyes of exited, so whatever. So now we can look at exited versus. We don't have that many. We just don't have that many. Yeah. I'm not gonna eat on stream. Is it done? Yeah. Okay, I'll eat in a bit. Okay. So I'm gonna wrap up soon to eat. I would like to just run one. Okay. One code to do all of categorical versus the numerical. Because we pulled in these two functions. So a distribution plot is going to show me box plots with a histogram. And this is going to show me more categorical. How do I want to do this? Do I really need to go one by one, or is there a lazy way to do this? And since this is for a class project, maybe lazy's not the way to go. Let's see. Okay. We'll do... There's not that many columns left is the thing. Okay. So we'll do exit versus categorical columns. Like I want to do what's my plot? It's my stacked bar plot, right? Yeah. So I can do stacked bar plot df geography, and that's going to show me that. So I can see really Germans so the French make up the most. and have nearly the same amount of customers leave. I feel like I could write. What if you do like for column, is this gonna work? Yeah, that's gotta work, right? Surname. Key error surname, because I dropped it. Did I drop that earlier? DF drop surname. Run it again. Oh, that's going to be annoying because if I run the whole book, it's going to always flag an error. So really, I just need to move that. Initial review, numplot. Yeah, I need to move you down until after. Yeah, there we go. Okay. Move that down. Now I have my two plots. Now what I need to do is print call. Is that going to work? Yes, it does. But I need print nothing to give me some space. Let's do it after because I put it after. Print there. There we go. What's that way? There's like a way to do like isn't it like times 20 or something? Yeah, there we go. Cool. So gender. Women are most likely. So women. Okay. 1 second. Okay. So women make up the lesser amount, but are more likely to leave. So infer from that what you will. And then from a geography standpoint, we have Germans make up the most. Cool. We always have to put our observations in the notebook. Observations from bivariates, categorical. We have, did it again. Women make up a lesser percentage of the overall customer base, but are more likely to attrite. And then we have Germans make up the second most of the customer base and are more like likely to attrite. Cool. Now we can do the other columns. Which is exited versus numerical columns. And we're going to shortcut that too by doing for call in df num columns. Yes, yes. Is it a distribution plot? Yeah, yeah. It's, so you have distribution plot, which is the function I created, the data frame. I didn't call df up here, right? Oh yeah, I guess it doesn't matter because it's looking for the columns in df. Okay, so you can actually leave that. And boom. And I'm going to have to run that again because I need to do print. Yes, yes, please. Bum, bum, bum. And now I can look at all these. Age. Interesting. So more uniform with outliers. Remove the outliers, right skewed. That seems to be fine. No change. Yeah, outliers there. So the characteristics of, what is this? What are you? Exited versus exited. Yeah. So the characteristics of age change. That's interesting. Credit score. Yeah, that's the biggest change. Save just in case, and then our observations. Observations. The biggest change when analyzing exited versus any of the numerical columns is that when we remove the outliers from age, the characteristic of the histogram changes from a more uniform distribution to a right skewed, biasing towards a younger customer base. Right? So if you like look here, you can see like around 50, we got 50 right in the middle. And then over here, it's more in like the mid 30s. And then we have a slight difference. And not really. Okay. I think that's good enough for streaming for today. So